Thanks everyone for joining. Thanks Shiba for the introduction. Is my screen visible?
Yes.
Cool. So welcome everyone for SaaS Engineering Talk. The topic of today's topic is journey from ops to platform engineering. My name is Pravanjan Chaudhary, co-founder Cloud, and been in Capillary Technology for a long time. I spent about a decade there. Today's talk is going to be focused a lot on our journey there and what we learned, how did we apply ourselves. I last couple of years in Capillary I spent as the CTO for the company. Um, the agenda is simple today. We're going to talk about a lot about dev, ops, the interdependency between dev and ops teams, developer productivity, cloud, and various other topics, platform engineering, the most. Uh, the it's mostly going to be two part. First part will focus on my journey in Capillary, a decade of ops, and how did we make the move um, from ops to platform engineering, and what were the internal motivations to do that. And in the last few years, there's a lot of talk that is going on the future of ops, which is future of DevOps, which is and how does the industry is now looking at this problem of developer productivity, making ops more efficient and things like that. We'll keep this talk interactive. I'm also going to post my contact details in the chat so that if the talk overshoots, then you can have a way to contact me later. All right. So coming back to the journey, I'm going to share a bunch of stories in the process of how did we stumble upon platform engineering? What are the key things that we finally unlocked? But before that, a little context on Capillary Technologies. Uh, for some of you who don't know about Capillary Technologies, probably more than a decade old now, focused on building loyalty, product, CRM, e-commerce, primarily for retailers and brands, and offers these solutions as B2B SaaS. We have two product lines, primary product lines, about 400 millions of transactions that hit every month to the platform, about 14 deployments globally, catering to various geographies, few $1 million of cloud spend, about 200 member engineering team that manages the cloud footprint, and about 150 microservices, primarily a microservices driven architecture, having real time systems, data platforms, AI workloads. And the focus is enterprise, super enterprise sort of a play, right? So that's Capillary Technologies, and simply, if you would have walked into a store, retail store, bought something, and you would have gotten an SMS saying thank you, you've gotten this much of point. That's probably quite likely Capillary in the backend. Now the product evolution, and that has a tight correlations to how the DevOps practices and evolved inside Capillary. 2020, 2012, I think I joined Capillary. 2020, 2011 is when the Series A happened. The focus was building a single product loyalty, like any of you SaaS companies who might be anywhere in this journey. Initially focused on building the loyalty product, single region, primarily India, and about 20 member engineering team with build success in India, having a single region of deployment, having single product. And over a period of time in 2015, we had a Series C. By then, there were multiple products that got added to the buffet. So there was a CRM product which got added, then the analytics for your transactions. It was now the company had expanded to Europe, Singapore, and other regions. Team has grown to about 70 member engineering teams. 2017, the product expanded even more. It was acquisitions. We acquired a company called Marjack, which was providing e-commerce for retailers and brands. The newer version of products got launched. The earlier version, V1 version of the loyalty, became V2, V3 versions of the loyalty products. And each of these things that I'm mentioning is essentially all these little things add a little to the DevOps, right? And 2019, we started moving up market, where starting to cater to super enterprise customers, having acquired bunch of brands and logos and built a name for Capillary, started moving up market and started selling to super enterprise customers. Team has grown to about 200 member. 2020 COVID happened, and that's a story for later in this deck itself, and how that forced us to rethink our DevOps. And 2021, I moved out to pursue the Facets, which is the internal platform that we built inside Capillary. And then uh, since then, there are a bunch of things that have happened: US market, more acquisitions, and the story continues. And what is the impact that has happened over all these years, right? So uh, the constant challenge that we faced over this journey has been that uh, the fundamental problem finally boils down to the larger development team or the growing tech team building various newer capabilities on the products, launching new products, or that through acquisitions and things like that, and being dependent on a smaller ops team, right? So and that manifests in various different ways, and I think we at many time don't realize this in our software delivery life cycle, is that these little things add a lot of things, or a lot of slowdown to which the pace that you want to really move. For example, let's say a loyalty team thinks about a new architecture, wants to introduce newer components. Then now they have to talk to the ops teams or raise few tickets. They would start writing the automations for it, get them delivered, and that slows down the overall process. There are tickets, there are verbal communication between teams, and things like that. And the systems, and there are so many things that goes on into your production. I'm sure many of you have realized that a developer, when he starts to look at an issue that has happened in production, he has to have all the information at one place. And having disparate systems, the resolving issues take time, and all these little things add to the developer productivity, or the way the desired pace at which you want to really move your systems. Coming to ops, time and again it has led to burnouts. The smaller team has always complained that they don't have enough bandwidth to do certain things. There are about, and practically if you look at a production system today, there are about 30 different types of categories of tool chains that are required to be operated in production to get the best out of DevOps. But it's almost like a chicken and egg problem, where the smaller team is always burdened with so many tickets that they don't have time to do that automations. And when they do those automations, most of the time the automations are either catching up, or those automations are only built for the teams themselves and not enabling the developers to do things faster. And more than even building, the maintenance of those systems took a toll on us. And there is, whatever you built like a year back, we have to revamp it. We don't know exactly what kind of automations were done, what was the thought process. A new person walks in, the automation processes change. And this sort of a area where there is no core focus per se. And we're not trying, but still it is very foundational for everything, right? And the final thing is cloud, where when this small team is so much of constrained in terms of delivering the automation, serving the development teams, the teams would not get to a lot of things, like for example cost optimization. You would, after a quarter, you would realize that the cost has slipped, and by the time you go and start fixing some of those things, and we call this by audits, and bring out some of those action items for the dev teams, that means that it's already started slowing down the development teams. Then increased workload due to compliance audits. Like every time there will be a compliance audit, there will be a bunch of tasks that would come to the development teams or the ops teams to do, and that would slow down the SDLC. And many of the time, and we would think about it that, okay, this is part of the SDLC process. But looking back in hindsight, all of these contributed to slowness in the SDLC pipelines, having DevOps ops teams burn out, and cloud being suboptimal. And as you would have seen in the journey itself, challenges in growing SaaS companies, most of you would relate this. The DevOps bottleneck is a challenge for growing SaaS companies. Where and why SaaS companies? Because there's a constant need to re-architect your system. You are, at the end of the day, selling your software, which needs to constantly evolve over time. Hence, agility is by far the most important thing for SaaS companies. Catering to multiple geographies. When we launched our first Europe region in I think 2014, we spent about a month in terms of setting up the infrastructure, then putting up all the configurations. Then again, the same exercise we repeated to launch our Singapore region. It again took about a month, because by the time systems, all the automations that we built for launching the environments, etc., got outdated, and then you go back and catch them up, and that essentially slowed down the development process. And not just about the newer environment, but also when the developers are now have to manage multiple environments and in production, and that adds to those little things which eventually slows down your software delivery lifecycle. When we moved in 2019 up market, many of the newer challenges started coming in, which is uh, uh, you have to probably deploy in private cloud environments. There is different expectation in super enterprise customers in terms of disaster recovery, in terms of SLAs, and those also added to growing complexities for SaaS companies. And expansion results in managing multiple product lines. Every SaaS company eventually, after a point, have to either build newer products around which they can sell it to the existing set of customers, or acquire and expand and try to do the same thing. And once you do that, you now have to manage multiple product lines, where you have to worry about standardization, developer experience across product lines, managing multiple lines, the ability to be able to move people around, and all these challenges started coming in. Cloud spend in SaaS companies is a concern. Like that's globally a big concern, but for SaaS companies, it affects your gross margins directly, and that's another area that you can't neglect. And security and compliance today is completely non-negotiable for SaaS companies. Now, having this journey, we what there have been different periods in terms of how we thought about automation inside Capillary, and many of the things that I'm talking here is in hindsight. Is that the initial days where we were uh, like any company, where we would focus on automation in our DevOps teams, and that did help to a certain extent, that the ops teams could get more things done. But there was a lack of self service, which means that the automations were built by the ops teams to ease their work, but they were not necessarily meant for the developers to do them independently. And that's the fine difference of automation that we later followed, that when we automate something, we give it to the developers directly. So the initial days, it was lack of developer self-service, no focus on, say, collaboration. In the second phase, where we started realizing some of these problems, growing number of products, growing number of regions, and supporting agility. When we started thinking about uh, self-service, where we built out the first version of the product, which we gave it out to the developers in 2018, I believe 2018 or 2019, where they can probably manage their own applications or own services. So they can create a new application completely independently, deploy it to the Kubernetes clusters in multiple regions and things like that. But what it didn't solve, and it did improve. I mean, we saw value that there's a lot of improvement in terms of the SDLC process, while it lacked many things that it lacked collaboration. First of all, there was limited view for the infrastructure for the developers who wanted to own it, and there was no uh, and the developers even wanted to, and there were even newer regions and other things, private cloud and other things, demand started coming in, where uh, only developer self-service was not enough. for application management, where we completely started focusing on developer autonomy, which is the next version of the internal product that we built, and where the complete application and infrastructure were automated, and more importantly, given the responsibility back to the development teams. For example, if you are running a pod and you're building a bunch of responsible for a bunch of microservices, you are responsible for not just your services, but also for your databases, your cache, your what goes inside your database, your dashboards, alerts, and things like that. And the DevOps team started moving from being owner of the infrastructure to started being the enabler of the infrastructure. And that's the primary uh, outcome that we realized, is that once this started to happen, when the chicken and egg problem that I spoke about earlier, when the developer were dependent on the ops teams, when the ops team started giving this tools and reusable processes back to the development teams, they started now innovating and catching up to the automation even faster. And it improved collaboration across teams. uh, Ops teams would sleep better. There would be single source of truth where everybody knows what is happening, and the ops teams also could set guardrails through which the development teams are free to do many of the things that could improve their speed of innovation while not being dependent on the ops teams. But as I said, many of the things what I'm talking about today is in hindsight. As I was saying, that all these little things adds to our slowdown in our development velocities, and we actually don't realize this. We think it's part of the process, or it's part of the SDLC, that there will be tickets, somebody will take a look at it, he'll approve, I'll do that after that. uh, or there is a migration, it will take X amount of time. But what we don't uh, uh, realize, and even we started to realize, that these are causing problems in your software delivery lifecycle. For many of us, it is a distraction. It is something. When do we start really, really focusing on it? While we built a hypothesis that we eventually have to create autonomy in development teams, but it was still not until we actually had to bite the bullet. Um, and that's the COVID story. And by that time, we knew that there were inefficiencies in our system, in our cloud management, in our DevOps processes. But COVID happened. It was like March 2020. All things were going fine, and our exposure to Capillary's exposure to retail was immense. And the COVID forced, and there was a revenue is literally within a 15 days or a month's time, the revenue really nosedived. Anish, who's the CEO of Capillary, has written extensively about it, what kind of hard calls that we had to take at that point in time. And that included not just relooking at your cloud cost, cut it down, look at your workforce cost, which was downsized. But there was also um, a point where we also realized that there are there are super enterprise projects which are still going on. And I mean, there are Capillary has already taken the journey to move to super enterprise customers. There were a bunch of projects which were already lined up, and we knew that even if our workforce is downsized, if we can make an effort to deliver them faster, we could recover from recover in our revenues. There was no view in terms of when the COVID will come back, but we had a view that if some of the projects, complex super enterprise projects, that we can fast track, then it can bring back all the revenues, most of the revenues. And that was the point that we were forced to think more and try to innovate, that how can we deliver more with less, right? And that time, the immediate discussion that came to our head is that, we have been talking about some of these efficiencies. Let's take a shot at it, even if we are short-handed. And we created a team called Foundation Team, and created a focus team which you could focus on creating this developer autonomy. And one of the projects which was getting delivered for Tata, who had a private cloud deployment needs, and we knew that itself is going to take us 1 month. And we as well might as well take a shot at it and see if we can not just do that, but also deliver the product faster, create efficiencies in development teams. And then about it took us about 3 months to put up all our learnings and create a product which we gave it to the development teams. Took another quarter or so to migrate all the infrastructure, all the environments onto it. But the results were phenomenal. We could not just create more efficiencies in delivering some of the products, we could also launch the Tata cluster within a month, within a day's time, right? And that created, and without adding additional developers or ops teams to manage those additional environments. And that immediately reflected in terms of how we could see some of the benefits of thinking of development autonomy upfront. And from that to today, Capillary does about 1,000 releases a month, probably even more than that. Reduced cloud spend significantly, or more importantly, sustained cloud spend, because now the ops teams are now free for doing focusing more time on various other things. Environment launch, whether it is non-production environment, test a new feature, load testing environments, or new production environments, they can just be done in minutes. And now the ops teams could focus on solving platform specific issues, freeing up time for more strategic work. I'll take a quick pause here to see if there are any questions. Cool. So yeah, that's been our journey in terms of uh, building an internal product for the development teams, rethinking DevOps uh, from ground up, to ensure that the DevOps doesn't stay in the critical path of the software delivery, but at the same time they become the enabler for the teams to do much bigger work or larger work and find out further inefficiencies and fix it, but not be critical path of today's release and today's problems. But now, how the ops now looking back, most of the things that I talked about is, as I said, in hindsight, and there were no reference points for us to look at as much to decide that whether this is a path that we had to take. But what we're now seeing is that ops is changing for good, and the future, we have all come full circle in software, in DevOps. So initially, in the early days, all engineers wrote code and ran software. Software and cloud were much simpler. Then came the era of DevOps, where some engineers wrote software, others ran software, and software and cloud continue to grow in that period. And then we come the full circle where now all engineers wrote code and ran software. And this is the world of extreme agility that we all live in, where it's not enough to push releases in a month. In 2 weeks, it's almost like multiple times a day, even tens of times in a day. And if you look at this kind of an agility needs, and you better be dependent on systems that you can work on independently. Think about a software developer. When he's developing his code, he's fairly independent. When he's doing his integration with working with the CI system or things like that, he's fairly independent. Now, when it comes to his code working alongside with many other tools in the cloud environment, that's when he's dependent on external knowledge, external teams, and other things. And if we can debottleneck that part of the SDLC, then only it's possible to achieve the kind of agility expectations of today's world. But at the same time, you can't overburden your software teams with additional responsibilities. You can't expect in terms of developer autonomy, we can't expect all the developers to understand all the cloud services, how they're deployed, how to deploy them securely, how to set up monitoring, observability, various the whole thing, right? So I mean that would lead to that cognitive load on development teams, that the decentralization will not only help and only slow you down, and that's where the platform engineering comes in. And and simply defining the many thought leaders in the space we've started talking about platform engineering, where simply saying it's basically provides a minimum viable self-service tier for the developers. This is by Charity Majors, CTO of Honeycomb. And what she talks about is it should be easy to do the right things, and it should be hard to do the wrong things for the development teams, right? So that would take care of 90 to 95% of the needs for the development teams, uh, where they could do the parts that they're responsible for under the organizational guardrails, under the constructs that are exposed to them. They should be easy to do it should be easy for them to do the right things. But at the same time, it should be hard to do the wrong things, where they can obviously either get the platform extended or talk to the ops teams. But that's the key philosophy of platform engineering, and that provides that minimum viable self-service tier for the development teams. Quickly, the difference between DevOps and engineering teams is simple. In DevOps teams, the DevOps teams are owner of the infrastructure. They do the capacity planning, scaling, performance tuning, etc. And in the platform engineering world, they graduate to become the enablers. They start enable internal teams to own their architecture in production, or own their own code in production. In the DevOps world, we think of infrastructure as code. In the platform engineering world, we think about infrastructure as a product, which is that minimum viable self-service tier that you would want to maintain and give it out to the development teams. The concerns into the DevOps world is that the infrastructure is scalable, secure, cost-effective, reliable, and you do your automations. And in the platform engineering world, developers can self their infrastructure efficiently, and it's the responsibility of the ops teams to create standard reusable components and processes and hand it over to the development teams. This is how the final, a typical structure looks like. It's you have your cloud infrastructure. The platform engineers are no more in the critical path of deployments. The developers own their environments along with their code. The SRE teams or site reliability engineering teams helps devs with reliability, and the platform engineers enables everyone to do their job better. Now, coming on to many of you would be in different part of the journey, and you would know your infrastructure well, but this is a typical. I mean, as I was earlier saying, that we don't think back often in terms of the developer productivity space, where and assume certain things would be part of the process and software delivery lifecycle. But let's look back and see what kind of cost it would have incurred in hindsight. For me, at least, there was this standard surveys and research that has gone in, where about 25% of development teams do waste time in terms of all these dependencies, in terms of managing their infrastructure, or spending additional time figuring it out issues, and other things, right? And in a typical SaaS company, if you look at it, the two primary spends are people and cloud, right? And this both concerns, both are in discussion here. So if you look at the teams, let's say you're in a typical scaled up late stage SaaS startup, about 70% of your spend would be on people. About maybe overall about 35%, 30 to 35% will be on tech. And if it's 25%, it's a large number that we're talking about. 7 to 8% of your total cost might be getting wasted. DevOps teams, which are typically smaller teams, but they waste about 80% of the time in iterative work in terms of supporting the infrastructure. And uh, and if your ops team hasn't got to all the things that would make your cloud optimized, then you could potentially be wasting about 10% of your cloud spend. And typically in late stage companies, it would be easily about 15% of your total cloud spend. So we're talking about close to between a 10 to 15% spend of your cloud total spend, which can potentially go wasted if you're not focusing on platform engineering. And you may be on different journeys, different parts may be good in your systems, and you can do your math for yourself. But I'm saying that in many cases, it could be a 10 to 15% of your cost problem that we're talking about. And how should you go about it? Uh, many of the cases, the prevalent knowledge is that we look at this last mile of the cloud as a bunch of integrations. We think that there are about all these tool chains that exist today. We'll do that integrations, and will create a solution to so that the developers whether the cloud is managed. But practically, at certain scale, you would start to look at it as almost like a product. Think about it like it has all the characteristics of a product. If all your developers are going to day in day out use it to make tens of software delivery every day, frictionlessly manage, uh, can get to root cause of issues, collaborate with other team members without explicitly being dependent on it. There's no tribal knowledge in the system. Then all these are characteristics of almost building it like or thinking it like a internal product. Some of the aspects that you would probably want to look at is collaboration, how teams can collaboratively take their architectures to cloud. It should have immense focus on experience. Even if a new developer that walks into your system should be able to get productive on day one. Should be extensible. Nothing is constant. Your cloud processes and everything would expand. Your architectures and needs will expand, and it should be a product that is extensible. It should meet all compliance and have needs to get you the best of all the DevOps tool chains that you can leverage. And everybody should be able to operate on this kind of system without making mistakes. And those guardrails are important, where every team can independently and deliver uh, deliver new architectures to the cloud without making mistakes. And that's the final side. And about 2021 is when I moved out from Capillary, explicitly interested in uh, pursuing this area in long term. The other co-founders, Anshul and Rohit, also joined in Facets.cloud as co-founders. Here's a LinkedIn where you can connect with me, and happy to discuss any further questions and happy to brainstorm on this topic. Thanks a lot.
Um, One of the question I have is, should we go to the platform engineering part directly, or the DevOps being right is a stepping stone towards that?
I would say that there are still a dearth of frameworks that can get you to ideal platform engineering now. So uh, you need to look at the main aspects of DevOps today, and maybe the right way to answer this is that maybe do a deeper study in terms of where all there could be leakages in your productivity, what all that you things that you see for the future, and when you think about your automations in your DevOps, think about not how the automations will make the life of the ops teams easier, but rather think about how those automations will make the life of the DevOps teams easier. So almost thinking about those reusable components with the dev teams can independently work on it and start prioritizing on areas where you think there are the most leakages in developer productivity?
Thanks. Praveen.
Yeah, I think there's one comment on by Sunny, which is a lot of times companies use some of these terms interchangeably. I've seen SREs to DevOps stuff and vice versa too. Yeah, that's true. Actually, um, many of the things is when you actually spend time going over it, is you can differentiate the responsibilities. But as I was saying, that the difference between platform engineering team and SRE teams, that platform engineering team enables everybody else to do their job better, and they add newer capabilities to the platform, which but used independently by the development teams. The reliability engineering team is what looks deeper into the to the infrastructure, to the environments, and ensures that the business, uh, the reliability requirements of the business is met.
Having said this, will there be any kind of impact?
Impact in terms of
Functionally or, technically as such?
I didn't get the question correctly, Vikram. Can you give me an example?
Yeah, maybe as you said, because what I understand is from a reliability point of view, it will be more of continuous, so there won't be any kind of room for interpretations as such. So when platform people are doing their job and reliability people are doing their job, will there be any kind of impact? Who's doing the best?
Uh, Probably don't think so. I think it's it's essentially, this the two roles are fairly different from each other, in my understanding, right? So the platform engineering teams are essentially now not just looking at how today's release will go through. Uh, they are more looking at now the overall things, like uh, how many releases have gone in the last 100 days, where have the developers spent more time, what are the capabilities in the developers are asking for, which is not yet there in the platform. So they're almost like a development team, which is building on top of the platform, while the reliability engineering team, the skill sets are entirely different, where they are looking at deeper and helping developers, in fact, having better uptimes, better SLAs, and things like that.
Okay.
Many of the small, early stage companies and even mid stage companies, sometimes these roles are mixed as well. There are same teams doing both work, but as you scale, it's probably a good idea to split them into two different teams.
Any other questions?
Hi, this is Ravi. Can I ask a question?
Yeah.
Um, so, so we can see definitely a lot of relevance in terms of challenges between development team and the infrastructure team talking about it. Um, uh, Definitely, we also see challenges because every developer builds a say an AWS Lambda. First, they try with the minimum memory and minimum timeout, and then as soon as they do the first test, they started increasing the timeout. They started increasing the memory. More data it comes in, they can expand it. So every iteration of this particular small component lambda needs to be talked to an infrastructure guy because he needs to go and change that particular parameter in, say, in a cloud. So this is getting really, really tough in real day, right? So for doing a particular lambda at the production ready, I would probably a developer starting would take even a 2 hours to 3 hours to fine tune that the configuration required for that particular functionality of the component. So how do you see this? But if you span out this to 50 lambdas, for example, just taking only the compute services in this use case, I can easily add up to so many hours of just an interaction time to fixing this infrastructure configuration for this particular compute function. So this will be faced by every company and every team. Um, do you see this can be solved, or are you destined to solve? It's already solved. What are your thoughts about it? Am I correct or am I wrong?
No, no, absolutely, Ravi, spot on. I think this is where so why do the ops team has to go and change on this behalf of the development teams is because you don't want to give the access to everyone, right? You don't want to give the access to everybody to go and change into a cloud environment. All the whether it is a pod sizes or this is lambdas, memory sizes and various configurations. But finally, who's making the decision? The decision is made by the development teams to increase it. And what the way that I would look at this is that there is uh, certain configuration limits within which the platform engineering team sets the guardrails for some of these components and exposes this ability for the development teams to change it within that limits and the boundaries, right? And this should be the development team should be able to do it on their own unless they are crossing those boundaries radically. But at the same time, the second requirement that comes in is essentially having a entire audit log flow, because this might have implications on cost. It might have implications of how environments have drifted from each other. One environment has different configurations, the other environment has different configurations. So what the platform engineering team will do is that it will create a construct where the development teams can change these configurations, but within certain limits and boundaries. But at the same time, have those audit workflows, have relevant role-based access controls. Not every developer should be able to change it. So maybe certain leads in the teams and certain people will be able to change it. But everything is audited to the extent that we know the implication of these changes in production. So for example, if there is a cost that is going to spike, then it is the responsibility of the platform engineering team to decentralize that cost and pass it to the development team. So whenever they're making these changes, they can track what is the impact of it. They can own the cost of it, those lambdas, as long as they can see it at one place. So when you're thinking about this problem, think of it how the platform engineering teams can expose this, where these three requirements are taken care. Guardrails, with limits, which the developers can play with. Second is the auditing, which is the development teams know if that made a change, they can go back and they can see what are the changes that they've made, track it in the past. And third is that the impact of those changes. And if you can pass on those information to the development teams, it's probably safe to follow this principle and give this access, give this controls to the development teams. Does it answer?
Yeah, problem. Thanks.
One question: what kind of components would platform engineering team has to manage? For example, different clouds, then different IAM roles, different storage, and so on and so forth, right? So, I mean, platform team has to take care of everything, right? Or should they? I mean, they can start with something in the beginning, then can move on. I mean, slowly by slowly, or yeah, only Facets Cloud allowed something to take care of those things in one go.
Yeah, so I think that's a good question. I think I would always start with applications first, which is like the easiest to give back to the development teams to manage it. Today's applications are mostly stateless, not always, but more often than not, and also the ones that changes the most. But also the ones that I would say are more cloud managed. The next part I would attack is things that are cloud managed. For example, your cloud hosted databases and things like that, which is for the developers easier to understand. But at the same time, we would want to give not the final things, but give intermediary layers which the developers understand. So on their part. So a key principle that I would probably want to just talk about here is that almost every environment that you speak about today for a typical cloud deployment, there are two parts to it. One part which the development teams understand, and one part is what the platform engineering or DevOps teams understand. Now, if you ask a development team, like, how's your cloud look like, they can draw a diagram on architecture, which is connecting different services, databases, and all that. What they don't know is how to take this and convert it to a cloud in a cloud optimized way, right? So the ops team's responsibility is to expose as much as possible that uh, the 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 boundaries of understanding of the development teams uh, are, they can operate within that knowledge base with the final cloud environments. I would say that the platform engineering team uh, should, obviously, there are, if there are complex stuff that we are managing, like for example, you have your own components for doing certain things, and those should be managed by the platform engineering teams. But certain aspects of that which the developers understand can be given back to the development teams. I think on mute, I guess.
If I'm basically building the platform engineering team myself, so suppose I'm leading the team, right? So how much things we should take care? Like, I mean, should we start with some kind of tool which is already there in the market, or kind of start something from scratch and maybe mimic that particular part first before kind of moving into the some kind of tooling which is already available?
Yeah, so as I was saying, that there's a dearth of tool that is available today, and in fact, facets. One of the key focus for us is to kind of build that tool chain, which people can use and get started quickly. There are other tool chains in the market which is also thinking on similar lines. So there are tool chains that are evolving at the moment. But if you have already begun on the journey of automation, there are uh, you know uh, there are certain steps, like I was saying, is that you could look at your existing software delivery lifecycle, see where are the inefficiencies are, and look at some of those point solutions which can start solving, and probably move incrementally into this. But yeah, it's there are no there's a lot that happened in the cloud in the last 10 years. Even people were trying to figure out what is the best way to deploy in cloud, right? Architectures were evolving. There were a bunch of debate that went on for a very long time between even monoliths and microservices, between pub sub, what kind of components do you use. But today, if you look at it, the well-architected principles are not too many. If you have to do certain things, if you have to deploy a particular type of architecture, there are probably 2 or 3 different ways to best practice architectures that are out there. Now, and also a bunch of things that has evolved in the last decade, which is now makes it possible to build platform engineering tools like Kubernetes, managed services, well-architected principles. How should you manage your IAM roles? How should you manage your credentials? So now it's possible to look at platform engineering tools. Having said that, the unified frameworks are little, and that's where we are also even working towards.
So one last question: how do we manage multi-cloud in such scenarios in platform engineering? What would be the approach for that? Just last question. Yeah.
Right. So the way that we have taken this approach in Capillary and in other customers as well is to, as I was saying, is that uh, there are fair bit of parity that has come up in the clouds in the last couple of years, right? So if you look at a Postgres, if you look at a blob storage, there are equivalent components in different cloud, right? Now, if you look at a architecture, as I was saying, is that any deployment, forget about the cloud architecture, multi-cloud first. Any cloud deployment that we talk about today has 2 parts to it. One part of it is what the architecture, and one part of it is the actual manifestation of the architecture to the cloud environment. So if you stick to this blue collar services in your platform engineering stack, which means that what the developers understand today is suppose a Postgres database, right? And he should be able to work with that knowledge with any cloud deployment of that Postgres server, right? Whether it is on AWS, whether it's on Azure, whether it's Aurora, or whether it is Cloud SQL, the developer understanding about the Postgres, or I mean, adding cognitive load onto him to understand multiple is something that has to be limited. But if you look at it, all the metrics that I need from Postgres, how to collecting those metrics, how to run them, deploy that securely, is an abstraction that can be kept with the platform engineering teams. But the abstraction that has to be exposed to the development teams is that I can request for a new Postgres as long as my, I'm authorized to launch a Postgres environment, Postgres server. Then it should be able to go and deploy that in cloud environments. The implementation of how this Postgres comes up in different cloud can be abstracted out from it. So, if you stick to blue collar services, expose the abstractions for the developers in the architecture that they understand, it's absolutely possible to manage multi-cloud environments.
Okay, sure. Thank you.
Any other questions?
Ranjan, maybe a short one, Ravi again. Can you just say three things one should not do, right? Just to keep it short. Thanks.
What one should not do, meaning in your current setup, like in dev.
Yeah, one should not do to increase the gap between the development team and the infrastructure team, which will reduce the productivity and increase the cost, right? Which is what we are trying to solve in terms of building this infrastructure engineering platform, what you just mentioned.
Yeah, I would say for practically for most tech companies or SaaS companies, application engineering teams. I'm just leaving out few extreme sort of tech, where there completely new type of innovations are required in terms of technology that you build. Probably deviating from standard well architected principles, right? Like if you're following microservices based architectures, just follow what is standard. And many of the times is what we've seen is that it's not just a ops problem per se, but when there are certain ways that you have architected your cloud, which is very different from the standard well architected suggestions and knowledge base that has come up in the market. And for example, let's say you're trying to think about credential management or securing your credentials. There would be like standard implementations of it, which is well tested, or principles, and it's a good idea to stick to those and not deviate from them too much, because some of those deviations leads to those tribal knowledges that this application or architecture behaves in certain ways, and that then becomes harder for platform engineering teams to manage, and then you build interdependencies between teams. So that would one point that's coming to my mind, really. Anshul, anybody else wants to answer this question? It's an open discussion, so feel free to jump in and
Right. Any final question? Otherwise, we'll go ahead and close the talk since it's 6 p.m. Okay. Thanks so much, Pravanjan, for giving the talk, and thanks everybody for attending. Hopefully, we'll have the next one. We don't have to wait for a few months for the next one. Bye. Have a great day.
Thanks a lot.
Thanks.